Hey folks, welcome back to physics. In this video, you're going to learn how to breaking apart vectors. By the end of this video, you'll be able to break two-dimensional vectors into their x and y components. So let's go ahead and jump right into things with an example. So we have Sam, who is going to walk 5 meters north at 53 degrees. Or 5 meters, sorry, at 53 degrees. So we want to figure out how many meters north he walked. So I'm going to start by just drawing my unit circle, and I'm going to go ahead and just do that in black. And so we've got our coordinate axes. Okay. And we know that Sam walked 5 meters at 53 degrees. So 53 degrees is going to be somewhere between 0 and 90. So we're going to draw Sam kind of like that, going about 5 meters this way. So here is going to be where Sam ends up. And this is obviously not drawn with a protractor and not drawn to scale. So I'm not going to just be able to count lines to figure out how far Sam went. But what I can do is I can just draw my sides as, I'm going to say A is how far east he went, and B is how far north he went as my two vectors. I'm going to go ahead again and draw in those components. The other thing that I know that I haven't yet added is this angle, which from the problem I know is 53 degrees. So to figure out what the components of our vector are, so what our x component A is equal to, in fact, I'm going to even rename our components. Sorry to do this, guys, I know it's confusing, but I think it might be easier in the long term if I just call my red vector x and my green vector y, since they're my components in the x and y direction. So in my problem, I want to figure out how many meters north Sam walked, which means I want to figure out what the length of y is. To do that, I'm going to need to remember my trigonometric identities. So remember, guys, so, ka, toa, sine of an angle is equal to opposite over adjacent. Cosine of an angle is equal to sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent, which apparently was on my mind earlier, is equal to the opposite side over the adjacent side, with the sides, of course, being the lengths of each side. So from my problem, I know my hypotenuse, and I'm trying to find y, which is my opposite side. So I've got hypotenuse, I've got opposite side. That means I am going to use sine. So what I can say is that the sine of my angle, so sine of 53 degrees, is equal to my opposite side, y, which I'm going to keep in green, divided by my adjacent side, or by my hypotenuse, which is 5 meters. So multiplying that out, I can say y is equal to 5 times the sine of 53, which gives me that y is equal to 4 meters. Now, one thing I would like to caution you on, guys, make sure that the mode your calculator in matches the angle. So if you're given an angle in degrees, you need to make sure your calculator is in degree mode. And if you're given an angle in radians, you need to make sure your calculator is in radians mode. So just be very, very careful when you do that. That is one of the most common mistakes that I see with these problems. So go ahead, make sure you give it a double check whenever you're starting a new round of problems. So again, we know that y is equal to 4 meters. And I don't have to find my direction because that's given my problem. It's 4 meters north. So there you know. There you have it, guys. You have figured out the y direction, the length of our y component of the vector. And I could do the same and figure out the x component. To do that, I will, of course, be using a different angle, or not a different angle, sorry guys, a different trigonometric identity. And in this case, I am going to be using cosine because x is adjacent to my angle, and my hypotenuse was given to me. It's not rounded like my y side is. So what I'll say is that the cosine of 53 is equal to x over 5. X is equal to 5 times the cosine of 53 and throwing that into a calculator in degree mode, I get that x is approximately 3 meters. So Sam walked 4 meters north, 3 meters east. I know my problem was just asking you to find north, but I wanted to make sure you could also find the x component of your vectors. So let's give another example. So now we have Frodo, who's going to walk 5 meters at 143 degrees. So we're going to figure out how many meters north he walked. So let's go ahead and again draw in our unit circle. So I know again 0 degrees, 90, 180, and 270. So I know that Frodo is somewhere between my 90 degrees and my 180 degrees in quadrant 2. And I'll go ahead and just draw a vector in quadrant 2, which I'm going to say is at 143 degrees and is 5 meters long. And I'll go ahead and add in the components of that vector. X pointing to the left and Y pointing up, or in this case, north. So you can figure out your sines and cosines for angles larger than 90 degrees. But what I want to do is I want to stick with our using these unit circles, these unit triangles. So what I'm going to do is go ahead and just put in my angle A right here, which is going to be 180 minus 143. And I just know that from the geometry of my situation. This straight line is 180 degrees, I'm 143 degrees. I've cut out 143 degrees, and so what's left is 180 minus 143. When I do the math, what I'll get is that this angle is equal to 37 degrees. So now I can figure out the values of y and x, or actually, for this problem, just y, right? So I only care about how many meters north he walked. So I know that I have my hypotenuse and I have my angle, and I'm trying to find my opposite side, so I'm going to use sine. So sine of my angle is equal to my opposite side y over my hypotenuse of 5 meters, giving me y is equal to 5 times the sine of 37, or y is equal to approximately 3 meters. So I have broken down my vector into one of its component parts. I could break it down even further and figure out this x component using cosine, but again, I'm not going to do that because my problem didn't ask me for that. So let's go ahead and talk through takeaways. So first of all, we can use cosine to find the x components of vectors and sine to find the y components. So you hopefully noticed through both of those problems the pattern that I was consistently using sine for my x components and cosine, or sine for my y components and cosine for my x components. And that is something you will find is the case almost all of the time with your vectors. Secondly, the quadrant your vector is in will determine the sign you will use. So going back to example number 2, had I found x was pointing to the left. So I would have said that x was negative, however many meters long it was, rather than positive. So if I'm going north and east, we're going to be positive. If I'm going south and west, we're going to be negative. And that's something that you will hopefully get more and more used to the more of these problems you do. So with that being said, go ahead and solve some more problems and get used to all of this. Best of luck and happy solving.